Hello students, Namaskar. In the previous lecture we talked about the kinds of matrices, and in kinds of matrices we studied row, column and square matrices. Here talking about the fourth kind of matrix, that is a diagonal matrix. Dear students, what is a diagonal matrix? A diagonal matrix is a square matrix. So here I am writing the definition of a diagonal matrix. A square matrix in which all the non-principal diagonal elements are 0 is called a diagonal matrix. Dear students, if in a square matrix all the elements, which elements? Non-principal diagonal elements. Non-principal diagonal elements are 0, then that square matrix is called a diagonal matrix. One more definition I am writing. A square matrix A of order n by n is called a diagonal matrix if Aij, the elements are 0 for all I is not equal to j. So hope you have understood, explaining you with some of the examples. Suppose, as I have mentioned in the definition, a square matrix. So a diagonal matrix always has to be a square matrix. Taking some of the square matrices, students, first of all I am taking a square matrix of order 2 by 2. Here I am taking a square matrix of order 3 by 3. Here I am taking a square matrix of order 4 by 4. How can these square matrices be diagonal matrices? These square matrices will be diagonal matrices if their non-principal diagonal elements are 0. So first of all you need to understand what is the principal diagonal of a square matrix. Dear students, in a square matrix the elements Aii are called the principal elements of principal diagonal. Means A11, A22, A33, so on, these elements are called principal diagonal elements. So apart from these elements, if all the elements are 0, then that particular square matrix is called a diagonal matrix. So making this square matrix of order 2 by 2 a diagonal matrix, what we need to do is to put these non-principal diagonal elements 0. Now here you may put any particular number, suppose 3 and 2 I have put. So it is a diagonal matrix as its non-principal diagonal elements are 0. Talking about this particular matrix, square matrix of order 3 by 3, in this the first element, suppose 3 I have put, then 0 0, then 0 2 0, 4 0 5. What you notice in this square matrix of order 3 by 3, these are the elements of principal diagonal. So apart from this, the elements of principal diagonal, all other elements are 0. All other elements are 0. Therefore this is a diagonal matrix of order 4 by 4. We may take, suppose 2 0 0 0 0 3 0 0 0 0 4 0 0 0 0 5. See students, I have taken a square matrix of order 4 by 4. In this matrix, all the elements which are non-principal diagonal elements are 0, therefore it is a diagonal matrix. So suppose if you are given a matrix and you have to check whether it is a diagonal matrix or not, what you need to do is to first thing to check whether it is a square matrix or not, and the second thing to check if it is a square matrix, its elements, non-principal diagonal elements are 0 or not. If a square matrix is satisfying this particular condition, then it is a diagonal matrix. I hope you have understood the definition of a diagonal matrix. I am talking about the next kind of matrix now, that is a scalar matrix. The fifth one, a scalar matrix. Dear students, the definition of a scalar matrix. A square matrix, or you can say a diagonal matrix. A diagonal matrix in which all the non-principal diagonal, or if you want to convert this into square matrix only, want to keep it in square matrix, a square matrix in which all the non-principal diagonal elements are 0 and principal diagonal elements are equal, then it is called a scalar matrix. The another definition of this one, a square matrix A of order n by n is called a scalar matrix. Scalar matrix if all the elements which are non-principal diagonal are 0 and aii is equal to c, where c is obviously a fixed number. So these all are diagonal matrices. To make these diagonal matrices a scalar matrix, we need to make these principal diagonal elements equal. So see, if I put here 3, making all of these elements equal, suppose 4 4 4 I have made, making these elements same, suppose 8 8 8 and 8. These have been the examples of scalar matrix. So now you can yourself define a scalar matrix. A diagonal matrix is called a scalar matrix if all of its principal diagonal elements are equal.